Hi, welcome to my video on more integral exponent problems. Integral exponents means integers, and integers are 0, 1, 2, 3, 4, etc. And the opposite of 1, 2, 3, 4 is negative 1, 2, 3, 4, so the integers. Simplify each known negative exponents, and normally when you work out exponents, you do not want any negatives unless you're asked. So we're multiplying, so the base is 2, so we keep the base. And when we multiply, we add. So 1x, 6x becomes 2 to the 7x. Now there's also another name here, but this could become 2 to the 7th raised to the x. And if you wanted to, 2 to the 7 is 128 to the x. So 2 to the 7x or 128 to the x. And number 2, we're multiplying. We have the same basis, so we add the exponents. 4x plus 2x is 6x. Positive 7, add on negative 3 is a positive 4. Again, we need the same basis. Notice we're dividing, same basis is 7. So when we divide, we subtract the exponents. So it's x plus 12, subtract negative 3x plus 8. So that's 7 to the x plus 12. And because we're subtracting, we can make that a minus 1. Negative 1 times negative 3 is plus 3x. Negative 1 times 8 is negative 8. So really, when you're subtracting, you're adding on the opposite, which is a positive 3x minus 8. 7 is the base. Add 1x, 3x is 4x. 12 minus 8 is 4. So 7 to the power of 4x plus 4. Number 4, we have the base of 5, and this is a power of a power, so we multiply. 2 times 2 is 4x. 3 times 2 is 6. Again, notice in this one I'm doing a little bit extra. And this is, again, 2 is the base. This is the power of a power. So we multiply. So x times x is x squared. X times 3 is 3x. 1 times x is x. 3x and 1x is 4x. 1 times 3 is 3. I did the FOIL on it, but I did it the fast way. And notice here we have a, b to the negative 2. So the b is to the negative 2, not the a. The a got a 1. So that's a times 1 over b squared, which becomes a over b squared. Notice the b is to the negative power, so the b moved down to become positive. Now, I did the two of these exactly the same, except this one has a plus and this one has a times. We always, the one rule that I use in math, always simplify the inside of the brackets first, and that's because of the PEMDAS. So, if we simplify inside first, we have a plus, so 3 to the negative 1 is 1 over 3. 2 to the negative 2 is 1 over 2 squared, which is 4. So I'll continue to simplify the inside. So common denominator is 12, so that becomes 4 over 12. 3 times 4 is 12, 3 times 1 is 3, so that becomes 7 over 12. When we add, keep the denominator, add the numerator. Because 7 over 12 is raised to the negative 1 power, we do the reciprocal, 12 over 7. Now in this one, I'm going to do it, because it's a multiplication, I'm still going to simplify the inside first. 3 to the negative 1 is 1/3 times 2 to the negative 2 is 1 over 2 squared, which is 4. That's 1 times 1 is 1. 3 times 4 is 12 to the negative 1. So the reciprocal of 1 over 12 is 12. Now, most people will take the negative 1 and move it in through here, but it's wrong. If you have a plus sign, then you can't move that negative 1 into here to get 1 and here and right here to get 2. because of the plus sign. You can do it with the multiplication, but not with the plus. So my rule is simplify the inside and then do the power on the outside after. Number 9, we have powers over powers. So we have 2. 3 times x is 3x. 3 times negative 1 is negative 3. That's a multiplication. So that's 2 multiplied. Negative x times negative 2 is 2x. 2 times negative 2 is negative 4. Now we have rid of the powers. In essence, we cubed it and squared it, but it's the power of a power. The base is 2. Because we're multiplying, we add the exponents. So 3x minus 3. Add on 2x minus 4. So 3x plus 2x is 5x. Negative 3 minus 4 is negative 7. And again, notice we have the negative 1 power on the outside. We cannot move that in through here because of that plus sign. So again, simplify the inside. So that's 1 over x squared plus 1 over y to the 1. So I'm simplifying the inside first. Now, the LCD here is x squared y. So that means I got to multiply this one by y over y. So that gives me y and x squared y. And I have to multiply this one by x squared over x squared. So that gives me x squared over x squared y. Notice the two of them now have the same denominator. So the LCD is y, x squared times y. So this one is multiplied by y over y. This one is multiplied by x squared over x squared. That gives us x squared plus y all over x squared y raised to the negative 1. Because it's raised to the negative 1, this fraction is flipped. So it's x squared y divided by x squared plus y. Again, I simplified the inside first by getting an LCD. This is rational expressions unit that you also, if you don't know, then review. But I'm assuming that you have rational expressions done before you did exponential functions. Okay, let's continue. Now notice we're dividing, base is 3, and we're multiplying. But notice this is a power of a power. So as PEMDAS, we always work out the exponent first. So negative 2 times 4x, negative 8x. Negative 2 times negative 1 is plus 2. Now that I got rid of the power, now I'm multiplying and dividing. So I'll divide first. So here we go. So when I divide, I subtract. So to subtract negative x makes it a plus x. To subtract negative 1 makes it a plus 1. And because I'm multiplying, I'll add. So notice I'm dividing, so I change that to its opposite, which is right here. And because I'm multiplying, I just added this on, didn't change it. So that gives me 7x and 1x is 8x. 8x minus 8x, so they cancel out. Negative 4 and 1 is negative 3. Negative 3 and 2 is a negative 1. And that's a negative exponent, so that's 1 over 3 to the 1, or 1 over 3. Now we have another different one. So this is like this is multiplied 3x to the 6 times 2x to the 4. So the 3x to the 6 is multiplied by this term and by this term. So that's a negative 3x to the 6 times 7x to the negative 5. So I'm distributing 3x to the 6 into these two. There it is. Because I'm multiplying, that's a 6x to the 10. Subtract 3 times 7 is 21. And we're multiplying, so 6 add on negative 5 is x to the 1. And the same here. I'm going to multiply this. So that's x to the negative 2 times, a to the negative 2 times a to the 5 plus a to the negative 2 times a squared. So when I'm multiplying, same basis, which is a, I'll add. Negative 2 plus 5 is 3. Same base is a. So negative 2 plus 2 is 0. So that's a cubed. A to the 0 is 1. And I can do this one a couple of ways. Let's see. I can take 10a cubed and divide it by 5a to the negative 2 minus 15a to the negative 2 divided by 5a to the negative 2. So 5a to the negative 2 is divided into both of these terms on the top. There it is. Now we simplify this. So 5 into 10 goes 2, and so that's a 2. And notice that's a cubed. So that's a to the 3. Because that's a negative, we're going to change. So that's 3, subtract negative 2, which is 3 plus 2. So that's 2a to the 5. We got a minus here. 5 into 15 goes 3. And a to the negative 2 divided by a to the negative 2 cancels out, gives you a to the 0, which is 1. So that's a 3. 15. I got a power of a power, so I'll do the power first. So x, b times 2 is 2b. So I did the power of the power first, according to PEMDAS. Now the top is simplified to x to the 2b. Now on the bottom, that's a b there. Make sure b plus 2. Because I have the same basis, keep the x. And that's a b, add on b plus 2, so that's a 2b plus 2. We add. So what I see is that I can take, that's x to the b squared, and that's 2 comes out, so x, 2 outside of b plus 1. So that's x to the b squared all over x to the b plus 1 squared. So the squares can cancel out, or the 2's can cancel out in your powers, or we can subtract them. So that's one way to do it. Another way is to go from here, right here, is to go, that's x to the, probably this might be the better way, x to the 2b, and because we have the same basis, then we're going to subtract the exponent, so it's a negative 2b minus 2. So it's x, they cancel to the negative 2, so that's 1 over x squared. This might be the better way to go. Because I'm dividing, I will subtract, so that makes negative 2b minus 2. 2b minus 2b cancels out, and x to the negative 2 is 1 over x squared. This is the better way to go, not this way. So I wouldn't, a little bit more confusing that way. And what we have here, I want to show you that this is 1 over 2 squared. This is 1 over 2. This is 1 over 2 cubed. Notice now that I have a complex fraction. So in a complex fraction, I would multiply at top and bottom by the same denominator. So the same denominator is the highest power, which is 2 cubed. When you multiply top and bottom by 2 cubed, then all the fractions will disappear. So that's the same as if I took this one, and the smallest power here is negative 3. So if I multiply the numerator by x, or 2 cubed, denominator by 2 cubed, watch what happens. 2 to the negative 2 and times 2 cubed is, because you're multiplying, you add, you get a 1. Multiply 2 cubed by 2 to the negative 1, you get 2 to the 2. When you multiply, you add. Negative 1 plus 3 is 2. When you multiply x to the negative 3 by x to the 3, 2 to the negative 3 by 2 to the 3, you get 2. You add negative 3 and 3, you get a 0. So that becomes 2. 2 squared is 4. 2 to the 0 is 1. So that simplifies to 2 over 5. The reason I wrote it like this, because if you went this way, you get rid of the negative exponents, and then you get your LCD, that's an 8, and that's a 2, and that's a 4. So your LCD is an 8. 2 cubed is an 8. So when you multiply the 2 cubed, that's why I left it like this and just multiplied without changing the negative. So you see, this is more advanced. Number 17 is very similar. Notice this is 1 over 1, subtract 1 over x. And this is 1 over x, subtract x. Because it's a negative exponent, is 1 over. This is a negative exponent, is 1 over. So the LCD is common denominator is x. So if you multiply this by x, x times 1 is x. 1 over x times x, it cancels out to give you a 1. 1 over x times x is 1. 1 over x times x, the x cancels. Negative x times x is negative x squared. So if you change the negative exponent to this and then did the LCD, because it's a complex fraction that we did in rational expression unit, we get rid of the denominator by multiplying the top and the bottom by the same LCD. But if you did it this way, and you multiplied the numerator by x and the denominator by x, because the smallest exponent is negative 1. So if the smallest exponent is 1, multiply it by its opposite, which is 1. So 1 times x to the 1 is x, and x to the negative 1 times x to the 1 is x to the 0, because you add. And when you multiply these two here, x to the negative 1 times x to the 1, you add, you get x to the 0. When you multiply here, 1 plus 1 is 2. So that's x minus 1 over 1 minus x squared. So either way, if you think about it, with the negative exponents, you multiply it by the opposite of the smallest. So the smallest negative exponent is negative 1, so you multiply by x to the 1. Now let's simplify this further. So notice this is x to the negative 1 all over negative x squared plus 1. So that's x minus 1 all over the negative of x squared minus 1. So what I did, I changed it to descending order, put the negative x squared plus 1. I factored out the negative 1. So that's a negative. So x squared minus 1 is the difference of two squares. So that's x plus 1, x minus 1. So the x minus 1s cancels out. 1, 1. So that gives me, that's a negative there. So negative into. So that negative 1 here just makes rather than have the negative on the bottom, positive divided by negative is negative 1. So a little bit different. That's what makes, now you're moving into higher grade, so you're going to encounter some of these problems. Just be cognizant of what I'm showing you and follow it closely. Now, right here, we can't multiply these right now because you don't have the same basis. So a 4 got to be is 2 squared. So a 32, if I'm going to simplify these, the 32 needs the same base of 2. So 32 is 2 to the 5. 32 is 4 times 8, and 4 is 2 squared. 8 is 2 cubed, so 32 is 2 to the 5. Now, 2, power of a power is x squared. Power of a power is, so Power of a power is 2 times x. I said x squared, so 2x. 5 times 2x is 10x. Power of a power, you multiply, and you multiply. It's because you have the same base of 2, you're multiplying, so you add. 2x, 10x is 12x. And again, there is another name for that, but again, you could go 2 to the 12, like that, and change 2 to the 12 to a certain number, but just leave it like that. And here we're dividing, but we need the same bases. So 27 is a 3 cubed. 9, I need a base of 3, so 9 is 3 squared. And normally, when you see these, if you look, like here, you got a 4, which is a 2 squared. 32 is a 2. 27 is 3 squared. 9 is 3 squared. So this is base 3s. So this is a power of a power, so this is 3. 3 times 4x is 12x. 3 times 1 is 3. And power of a power, 2 times 3x is 6x. 2 times negative 4 is negative 8. And notice we have the same bases. And when we do, we subtract the exponents. So that's 12x plus 3. We're going to subtract. So that's when you subtract. I could do this as an extra step. So here, because I'm dividing, I'm showing you the subtraction. So that's 3, 12x plus 3. When you subtract 6x, you get a negative 6x. When you subtract negative 8, you get a plus 8. That's a 12 there. So that's, add them up, 6x plus 11. So again, because you're because you're dividing with the same bases, you subtract. So I'm putting the subtraction in here to show you that this becomes negative 6x plus 8. Now I'm going to do this one in 2 ways. One way would be to do this. So x to the negative 4 is divided into both of these. That's like having 4x plus 8 over 4. So the 4 is divided into the 4x, and the 4 is divided into 8. So that's what I'm doing here. So this becomes x 5. You're subtracting, so that's a plus 4. That becomes x to the 9. X is the common base, so that's negative 3. You're subtracting, so you get a plus 4. So that's x to the 1, or just x. That's one way. Another way, because you have another way is to find the smallest exponent, which is negative 4. Multiply top and bottom by x to the 4. When you multiply the bottom by x to the negative 4 by x to the 4, that gives you x to the 0 because you add. And when you multiply these two, you get 5 plus 4 is 9. When you multiply these two, you get x, negative 3 plus 4 is 1. So that becomes x to the 9 plus x. X to the 0 is 1, so it gives you x to the 9 plus x. So that's the 2 different ways. One is to take x to the negative 4, divide into both of these, and then simplify. Or the other way is to, remember, you got fractions. So remember, this is also x to the 5 plus 1 over x cubed. And that's 1 over x to the 4. So if you change your negative exponent to this fractions, you have complex fractions. So to get rid of this complex fraction, the LCD is x to the 4. So that's why I'm doing x to the 4 without showing you this. But if you did that and multiplied, then what happens, you can see that x to, see, they cancel out to give you the 1 on the bottom there. No? And x to the 4 times x to the 5 is x to the 9. And when you multiply 1 over x cubed by x to the 4, you just get x. Because when you multiply, x cubed divides into x4, just x. just different ways to show you. And number 21, you don't want to, you try to get the same bases. So 27 is a 3 cubed, and that's a 3 cubed. And 9 is a 3 squared. Notice all the bases are the same. So this is the power of powers, so this is 3 to the 12. This is the power of powers, so it's 3 to the 12. And because that's 3 to the 12 and 3 to the 12, then you can cancel them, and you get 3 cubed, and 3 cubed becomes 27. Now, if you wanted to, but you would, because they're the same, because that's multiplying, you can cancel them. Man, you could have if you wanted to, but you just cancel them here. You could say that the top is 3 to the 15, the bottom is 3 to the 12, and that, because you're dividing, you subtract 15 minus 12 is 3, and you get there. But it's easier to, because you're multiplying, you can cancel those out. And that gives you the 27. So that's extra problems pertaining to the exponent rules. And you'll find that in the chapter that we're going to do. You need those skills. And if you like my video, click on the like button, click on the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.